All right, we're going to evaluate functions. And so let's suppose we had, now remember function notation. So let's talk about function notation to begin with. All right, so we know that y equals 2x minus 1 is a function. Why is y equal 2x minus 1 a function?
Mhm.
What do you think?
Because it will have a set of points on there. There will be an x and there will be a y. I mean, you could solve for both and you'll have a set of points.
Well, a circle is a set of points, but it's not a function. Why is that a function?
It's an ordered pair.
Okay, well, they are a set of ordered pairs, but not all set of ordered pairs are functions. Some are, some are not.
There's only one, each x coordinate only has one y coordinate.
Yeah, but how do you know that for each x coordinate is only y coordinate? How do you know that?
There's only one of each.
So, for example, next semester, you're going to have this.
Y squared equals 2x.
Now, that one next semester, you're going to see that's not a function. So your idea there's one of each doesn't apply here.
The
But-
exponent is 1.
Not necessarily. It could be. It could have been y equal 2x cubed minus 1. It has nothing to do with that. What I wanted you to say was, well, the graph is a what?
Line.
A line. You turned in all kinds of stuff with lines, right? Did you graph something like this?
Mm-hmm.
It's a line. And what is the only line that's not a function? A vertical line. And what does a vertical line look like? Yeah, don't say straight up and down. Okay, let me rephrase it. Let me not use the word look like. What does the equation of vertical line entitle? What's in the equation of a vertical line? X
Whatever.
equal a number. Is that a vertical line? No, that's not a vertical line. In fact, when you graph it, use a t-table. If x is 0, I get y equals 2 times 0 minus 1, which is what? Negative 1. So 0, negative 1's right here. When x is, let's say, 2, I get y equals 2 times 2 minus 1, which is 3. So 2, 3. And this is what I get, right?
Mm-hmm.
It passed the vertical line test. So what I want you to recognize were those were lines, and the only line that's not a function is a vertical line. And that's not a vertical line because a vertical line is x equal a number. Okay? All right, now, notice though, I'm using a t-table, right?
Mm-hmm.
So in place of x, I'm substituting 0. In place of x, I'm substituting 2, and so on. Well, there's something called function notation. So instead of saying y equals 2x minus 1, I could say this. So here's function notation. All right, so I can replace the the y with this notation, f of x. This is read f of x. That's how you read this, f of x. That's function notation. So instead of saying y, I'm going to say f of x equal 2x minus 1. They mean the same thing, though. F of x is the same thing as y.
See, this is
Oh, that's not going to be confusing at all.
this one math gets ridiculous. Why can't you just say y?
Because you could
F of
have,
X.
well, because here, because there could be situations where you can have more than one function, so they have to have different names. You can't just call all your functions y's. You have to have different names. So, for example, I could have another function that's called g of x. So g of x is 3x squared minus 1, let's say. I could have another function that's called h of x. H of x is, let's say,
8x cubed.
the absolute value. Let's do absolute value. Absolute value of x minus 1. So those are three different functions. So if they all were y equal, you really wouldn't know which function I'm referring to when I say plug in for x. You would have to say, well, which one are you talking about?
And all of that more complicated stuff is in the regular algebra class.
The college algebra?
Mhm.
Oh yeah, much worse. So you better know that before you get into that college algebra. All right, so here's what you can do with that. I could say, all right, let's find a g of 0. Find g of 0. Well, I know now which function I need to go to. Which function I need to go to?
G of x.
G. The function g. And that's the one that says 3x squared minus 1. And wherever I see the variable x, because remember this takes the place of what? X. Wherever I see the variable x, I substitute 0. It's kind of like a t-table. I'm going to plug in what for x? 0. You're really using the idea of a t-table here. So g of 0, then, again, wherever I see an x, I see the x here, right?
Mm-hmm.
So that's going to be 3 times 0 squared minus 1.
-1.
Just like a t-table. So if this was y, which it's not, but if it was, and you did a t-table, remember that t-table, if x is 0, you'd say y equals 3 times 0 squared minus 1, which is -1. Same thing. So g of 0 is what? -1. All right, now listen carefully. So in the blank on the worksheet, you're going to say g of 0 equal blank. What are you going to put in the blank? -1. All right, now keep in mind what this means.
Mm-hmm.
Okay, in terms of an ordered pair, that means if you were to graph this stuff here, that means that x is what? 0, and this -1 is your y. Okay, so the ordered pair
Is 0, comma, -1.
is 0, -1. That's what that is.
That's not as terrible as it looks, I suppose.
Still
So in part B, let's suppose you had h of 2. Let's not do h yet. Let's do f of 2. F of 2, how do you find f of 2? Well, which function do I go to?
F of x equals 2x minus
Correct, so I go here. And wherever I see the variable x, what do I substitute?
2.
2
So you would get 2
times 2 minus 1, and then use the order of operations. 2 times 2 is
4.
4. 4 minus 1 is
3
3. So f of 2 is
equal to
3. And if you were to graph this, remember you can graph functions. You're going to graph functions now, next semester. If you were to plot this ordered pair, what would be the ordered pair you would plot? What's x? 2, and this 3 represents
y.
y. Because in terms of the t-table, that's what it is, right?
Yeah.
f of x is the same thing as y.
Makes sense.
So if x is 2, then I found my y value. My y value is what?
3.
3.
I understand you saying if you f of x, you go to that chart and get that from up there, but then you said x is equal to 2, and I don't understand how you got that.
I'm making that up. I'm just saying x is 2.
Oh, okay.
I mean, we did a t-table. You could put any number you want for x, right? When you graph lines,
Right.
you can use any number you wanted to.
Oh,
So I could have said, I want to find f of 1 million. I wouldn't do that, but you could find f of 1 million if you want to.
okay.
It doesn't matter. So you want to find f of -1, what do?
Plug in -1.
You plug in -1 into x. So it's 2 times
-1.
-1 minus 1. What's 2 times -1?
-2.
And what's -2 and a -1?
-3.
-3.
And y is equal to -3.
So in the blank, you would say f of -1 equals -3. Now, if they asked you, there's a question there about the ordered pair. The ordered pair would be -1 comma -3.
I'm on the verge of understanding it.
So then, if you had h of 6, now remember, this time, what's your function h?
Function h is h of x equals absolute value of
X minus 1. So then that becomes absolute value of x, and what's x here?
6.
Minus 1.
So absolute value of 5.
Okay, 6 minus 1 is 5. Absolute value of 5 is 5. And what's the absolute value of 5?
5.
5. All right, so you would say h of 6 equal 5.
I think I might have it.
Then if you had h of -2, you would say, well, that's going to be the absolute value of, remember, h of x, you got to go to the function h. H of x is absolute value of x minus 1. So that's -2 minus 1, right? What's negative 2 and a negative 1?
3, and it's gonna be absolute value of 3.
No, no.
I mean, it's gonna be, the same, the final is gonna be 3.
Okay, 3, right? 3. Okay. All right. And it's all this was. Now let's suppose you had this. Suppose k of x is negative 2x squared minus 3x plus 1. And you want to find, let's say you want to find k of 2. K of 2. So what do you do?
All right, well, we go to our handy.
All right, now a couple of you walked in. Did y'all turn in the worksheets? Turn the worksheets. All right, so how do you find k of 2?
You would replace the 2
So the
where
corner.
the x is.
Let's go in the corner. Where we see an x, you plug in 2, right?
Yeah,
So how many x's do you see?
there's 2
Two.
x's.
There's 2 of them,
So negative 2,
You can just put it in the stack.
but you got a 2 in the second.
Just put all the stack.
yeah. Well, negative 2 multiplied by 2 to the
2
second
squared.
power,
Minus 3 times x, and what's x?
negative.
2 plus 1. So again, wherever you saw the x, you plugged in
Yeah.
2, right? Okay, order of operations. I do exponents first.
So 2 times 2 is 4.
Now, technically you would do parentheses, but there's always see in parentheses is just a number 2, so there's nothing you can do.
Negative 2 times 4 is negative 8. Then you would
That is,
Negative 6.
distribute.
you're multiplying 3. Let me go ahead and write it
Yeah,
over.
yeah.
Okay, so all you did was the exponent first. So now we're going to do multiplication from left to right. Negative 2 times 4 is negative 8.
And then,
Write everything else over.
negative 3
I still have
times 2 is
multiplication.
Negative 8 minus 6 plus 1.
Okay, then we do a subtraction addition from left to right. What's negative 8, negative 6?
Minus 6 is going to be negative 14, plus 1 is going to be negative 13.
Okay, so that's about it. So you should be able to do this.
And that was
So
an
there-
easy one, huh?
So you had this your function f. You want to find each of
Don't
those.
encourage you.
You have your function g. You want to find each of those. And you have your function h. You want to find each of those. And then this is where you have to find the corresponding order here. Right here.
Alrighty.
Okay? All right, so that takes care of that. Now let's look at, you picked up some graph paper. So take one, pass the rest back. Okay, so this is where we're going to start graphing some basic functions. In next semester, you're going to talk about shifting and stretching and all that. We're not going to talk about that in here, but you need to know how to graph these basic functions before you can go further with those next semester. So let's look at this. Let's graph, and we're going to start with an easy one. Let's suppose I want to graph f of x equal x squared. F of x equal x squared. Now that's a basic one. So this we're going to call the parent function.
Do you want us to write on these graphs that you gave us?
Yeah. All right, parent function. And so when graphing this parent function that's x squared, this is called a quadratic function. It's a quadratic function. So the part that makes the quadratic is the exponent 2. And the graph is a parabola. And the graph's a parabola. And the parabola looks like this. It will have this shape. And in the handout you saw yesterday, you had those shapes on it. So either going up or it could go down. So that's what a parabola looks like. And remember when we did domain and range the other day? You had those graphs. So those would be called parabolas or quadratic functions. But that's the shape of a parabola. Either goes up or it goes down. Notice the arrows. Either the arrows are pointing up or the arrows are pointing down. The low point right here, this low point, that's called the vertex. And this high point right here is also called the vertex. So the vertex would be where the parabola changes orientation, how I'm going from decreasing to increasing, where I'm going from increasing to decreasing. You will have to talk about increasing and decreasing next semester. You're not going to talk about increasing, decreasing here. So next semester we'll be dealing with the intervals where functions are increasing, intervals where functions are decreasing, intervals where functions are constant. So all that's going to play out next semester. So for the parent function x squared, for the parent function, you're going to use these values for x. So you use a t-table, and we're going to use these numbers. 0, 1, -1, 2, -2. And the grid that you got the maximum is 9 and the minimum is -9, so we can go 3 and -3 as well. So that should be fine. Okay, so these are my x values. I want to find my y value. So on here, I'm going to graph, first of all, I'm going to graph f of x equal x squared in here. And I'm going to use these ordered pairs to help me do this. Now, this is not a line, so don't just use 2 or 3 points. These are curves. Remember, the lines that you turned in, you use 3 points. Or if they ask you to find the intercepts, you only use 2 points. But those are not lines. So you see how many points I'm using? Quite a few. All right, so if x is 0, this says this becomes 0 what?
Slow down just a little bit more.
0 squared.
0 squared, right?
Mm-hmm.
Which is what?
0.
0. So if x is 1, this becomes 1 squared, which is what?
1.
1. If x is -1, now be careful, you're squaring that -1, so don't say the answer is -1.
It's 1.
It's 1, because this is, the thing is being squared, the thing that's being squared is -1. So this is really -1 times itself, which is +1. So when I start graphing those or plotting those points, I get 0, 0, 1, 1, -1, 1. That's what I get so far. And then if x is 2, I get 2 squared, which is
4.
4. When x is -2, I get -2 squared, which is also what?
4.
4. So I get these points. 2, 4, -2, 4. And you can actually see the shape of that parabola. You connect the dots in a curve, you can actually see it. But let's do the 3 and -3. If x is 3, what's 3 squared?
9.
And if x is -3, what's -3 squared?
9.
So you get this. You get 3, 9, and then -3, 9. And if you connect them, just like this, you get that parabola. You do the best you can with connecting these. It's supposed to be a curve, so don't use lines. So you get something like that. So that is a parent function x squared. Okay. All right, now let's look at this. Suppose I want to graph this. Let's call it g of x. G of x equal x squared plus 1.
So this will be on the next one that we.
No, let's go ahead and do it in the same one because you don't have that many grid papers.
Okay.
So just try and do 2 on each one.
Okay.
So x squared plus 1. Let me make sure it's not one of the. I don't have those worksheets. I left them. I don't think x squared plus 1 is one of them. Huh? I passed it out. Just come and get some right here.
Oh, yeah.
3 sheets of it. That's what
Yeah.
everybody's got.
Okay, so x squared plus 1. I want you to notice what's going to happen. I'm going to kind of use the same points for x, and let's see what happens. Okay, so if x is 0, I get 0 squared plus 1, right? What's 0 squared plus 1?
1.
1. So then I'm going to plot the point 0, 1. I'm going to plot the point 0, 1. I get this. You see this right here?
Mm-hmm.
Okay. If x is 1, I get 1 squared plus 1,
2.
which is 2. So then I get the point 1, 2. I get this point right here.
So basically, you're probably going to have another one just doing it on the inside
Mhm.
of that is what we're getting at.
So what do you mean by that?
Basically, you see how that is? It's just going to be a smaller one on
A
the inside
parabola
of it.
within a parabola.
Yeah, within one.
Well, it's not really going to be small. It'll be the same size. It's just that it's shifted up.
Ah, okay.
Okay. So it's the same size. It's the same size. At a transparency, you would see that. But basically, if you take a transparency, and I didn't bring one. I used it in college algebra. But if you take a transparency and then move it up, you're going to get what you're referring to.
Yeah.
Okay. So it's not really small. It's just that it looks small because it's being shifted, which is still inside that other one. So if x is negative 1 rather, I got negative 1 squared plus 1, which is 2. So I get this right here. If x is 2, I get 2 squared plus 1, which is
2 is 4, plus 1 is 5.
5. So 2, 5 is here.
There you go.
Now again, see how it looks like I didn't grab this very well because it's really not supposed to touch this one. So it should have kind of did this. See this right here? It should have done that. But anyway, this is what we get.
Is there a type of tool that you can use to draw those perfectly with the curve?
On paper,
Yeah, like we use
No.
a ruler to do a straight line.
no. Nope. All right, if x is, let's say, negative 2, you get negative 2 squared plus 1, which is,
Negative 2 squared is 4.
so 5 as well, right? So negative 2, 5, that's about here. Okay, so if I just kind of graph what I have so far, I get this. All right, but what I want you to notice is that this graph I just drew, g of x, is f of x, but what did we do at f of x to get g of x?
Added one.
We moved it up 1. So all these points, see these points right here? I want you to notice all these points that were on f of x, I shifted it what?
1 up.
Up 1. I shifted it up 1. Okay? But notice I still use the same x values, right? I still use those same x values. But what I want you to notice, though, whenever you have, this was g of x equal x squared plus 1. You remember, this is called the parent function, x squared. You know what that looks like. So you graph x squared. The vertex of x squared is located at the origin, right? So here, this says I'm taking the parent function. I'm covering this up. I'm taking the parent function, but instead I'm adding 1 to that y value. So when I add 1 to the y value, the graph is shifted up 1 because I'm adding 1 to this y value. This y value is 1. 1 plus 1 is what? 2. This y value is 4. 4 plus 1 is 5. That's what you're doing. So g of x is f of x shifted up 1. Shifted up 1. Okay? Yes?
You're gonna always use those same numbers that you have for x?
Okay, that's a good question. I am going to use the same numbers for x if it's a vertical shift.
Is it so it's gonna always have the same numbers you're supposed to use, like when you do that on?
If it's a vertical shift, you're going to use the same numbers for x, yes.
Okay.
Okay? Use the same numbers for x. So we're dealing with here is a vertical shift. So, and if you recognize that's a vertical shift because that number 1 is on the outside of the parent function. Now see that? The number 1's on, if this is my parent function, I'm adding 1 outside of it, right? It's on the outside. So if it's on the outside, it's a vertical shift. Plus 1 will indicate I'm going up 1. If this is x squared, let's say this was g of x equal x squared minus 3. Then for that one, I go what? X squared minus 3.
You'd be going
You'd be going down 3. All right, so your parent function shifted down 3. So you could still use the same values for x. Same values for x. But you don't have to do that. You know that if this is a vertical shift down, that means you take, when you grab that x squared first, you take all those points and do what with it? Go down 3. Just go down 3. Now, if you want to use a t-table, go ahead. You'll get the same thing. So for example, we were talking about g of x equal x squared minus 3. Let's use a different function for that. So let's call it h of x, because I already had g of x up there. So h of x equal x squared minus 3.
That's G of the,
Say it again.
what that number is that you have?
Right here,
That's the H.
that's h. H of x.
H of H.
Yes.
It don't look like what it is.
All right. I know. It's h of x. All right. So if we use 0, 1, -1, 2, -2, and so on, right? So if x is 0, what's 0 squared minus 3?
-3.
-3. Kind of makes sense because we said that this says I take x squared and do what with it?
Subtract 3 from it.
Move it down 3. So 1, 2, 3. That's where we are. Then if x is 1, I get 1 squared minus 3, which is a what?
-2.
-2. It better be -2 because this says I take the point where x is 1 here and I could do what to it? Go down 3. 1, 2, 3. And is that 1 -2? Is that 1 -2? Yes. And you keep on doing this. But do you have to do all this that I'm doing?
No.
No, you just use the fact
Take your
that you
parent
know
function and subtract 3 from it.
that h of x is f of x
Minus
shifted
Down 3.
down 3 units. That's all it is. Can't see it, but that's all it is. Shifted down 3 units.
It's definitely looked
It
a
might
lot
help if
worse.
you zoom out a little bit. It might show more on the measure.
So you can see right here that these points right here are these points here, and it's really these points shifted down 3 units. So if I do -1, which is this point here, what do I need to do to this point? Bring it down 3 units. So let's see what we get. We get -1 squared minus 3, which is 1 minus 3, which is a -2. And that's what we're supposed to get. So 1, 2, 3. And you keep on going if you need to. 2, if x is 2, I get 2 squared minus 3. 4 minus 3, which is what?
1.
Which is 1?
You put 4 minus 1. Perfect.
Yeah. So I get 2, 1, right? But I knew it had to be 2, 1 because
Just went down there.
I went down 3 from here, right? 1, 2, 3.
1.
And over here, same thing.
-2, -1.
Yeah. I'm not sure why I put -2, 5. Was that? Okay, yeah. All right. So here I go down 3, right? 1, 2, 3. And so then I get this graph. Now, if you had different colors, you'll look better. But you get this. And that's it. So for this little part, I need for you to know what x squared looks like. So x squared. So you're going to be told to graph the parent function, x squared. And then from there, you can be asked to possibly graph x squared minus 5. So once you know the parent function, what do you do to graph x squared minus 5? Shift everything down 5 units. If it was x squared plus 6, you would shift everything up 6 units. And that's all you do. So you have to recognize that this right here, those functions h of x and g of x are vertical shifts. So move up and down. Okay? Let's talk about horizontal shifts. Let's see what it looks like if it's a horizontal. All right, so watch this. All right, so still dealing with the parent function f of x. So let's graph f of x again. All right, you are at some point you didn't know in your mind what the points we're going to use for x squared. So if x is 0, what's the y value? 0. If x is 1, what's the y value?
1, 1.
1. If x is 2, what's the y value? 4. If x is 3, what's the y value? 9. And you're going to learn next semester about symmetry. So you see how these parabolas look symmetric about the y-axis? Okay. So x squared is symmetrical about the y-axis. So you're going to get negative 1 what?
Negative
1, negative 2, 4, and negative 3, 9. And then you just graph, do the best you can with this.
We can do that on the test, even though you ain't showing no work, if we just know it like that.
Yeah. Yes. Okay. All right, so that's what it looks like. All right, now what I want to do is graph g of x equal, now horizontal shift looks like that. Remember, vertical shift, the number's on the outside of x squared. So I want you to look at this.
G of x equals x minus
See that this is not x squared minus 2, so it's negative 2 on the outside of my x squared.
Repeat the question. I'm sorry.
Is negative 2 on the outside of x squared? Does that? No.
It's part of
Negative
it.
2 is inside the parentheses being squared, right?
So it's your x-axis.
So
that's getting
so
squared from.
so that is going to be a horizontal shift. That's going to be a horizontal shift. So let's talk about horizontal shifts. All right, so this is a horizontal shift.
2 places to left.
All right, horizontal shift. Okay, so listen carefully. So we're gonna do this one by hand, and you're gonna see how it's shifted. It is very easy to think wrongly here. So for example, well, I'm gonna wait. All right, so let's do this one. Okay, so I want to graph g of x equal x minus 2 squared. I'm going to do this one by a t-table, just to kind of get the graph to show you how it's shifted. Okay, if x is 0, I get 0 minus 2 squared, which is what?
Hold on, we're still right.
4, right? You got 4?
I was trying to make sure I still had these done for this one so I could mark the shift.
You got 0, 4? Okay, so far I get this point. I want you to notice something. I get 0, 4, right?
Where's the math here?
I get 0, 4. I'm sorry,
What happened?
because this is 4, 0.
Oh,
I get 0, 4.
I didn't even notice. So.
I get 0, 4, right?
Mhm.
Okay. All right.
Could you show me the work for that one? So I could just write
0 minus 2 squared
Okay.
is negative 2 squared. Negative 2 of negative 2 is 4. If x is 1, I get 1 minus 2 squared. What's 1 minus 2?
Negative 1.
Negative 1 squared is
1.
1. So I get 1, 1, right? So I plot the point 1, 1. So 1, 1 is here. It's right here.
You already got 'em.
Okay.
You got one on the other.
Now let's look at 2. If x is 2, I get 2 minus 2 squared, which is what?
2 minus 4 is negative 2.
What now? 2 minus 2 is 0. 0 squared is still 0, right? So I get 2, 0. So 2 zeros here. Y'all agree? Okay. Let's look at 3. I get 3 minus 2 squared, which is 1 squared, which is what?
1 squared is 1.
1. So I get 3, 1. Okay, let's look at 4. If x is 4. I got 4 minus 2 squared, which is what? 2 squared,
4 minus 2 squared is 4.
which is 4. So I get 4, 4. You see what's happening? Does this. So those x values are a little bit different than the others. But I knew which x values to use for this purpose. But what I want you to notice, though, is g of x that I'm pointing to, is that a vertical shift or a horizontal shift?
Horizontal shift.
It's horizontal, and you shift the parent function which way?
In the opposite direction.
To the right. Shift to the right.
Because
So-
what I was curious about is that you had you were subtracting 2 from x. but
No,
you
that's not really what's
shifted
happening,
to the
though.
right.
Yeah, no, you're not subtracting 2 from x.
So,
I have a question.
Yes,
So then, I mean, how many ordered pairs do you know to
you need at least 5.
at least one?
So what I would do is I would determine the vertex, and then pick 2 points to the right, 2 points to the left. Okay. So our question was, how many points do we need? And it's a legitimate question. You need 5. One of them has to be the vertex. So 2 points to the right of the vertex, 2 points to the left. But most students mess up on this one because they see x minus 2 and they see that negative 2. So they think, well, I'm going to shift, since it's negative, I'm going to go to the left.
that's sure the first thing I
It's-
thought.
It's really the opposite. You do the opposite. So you're going to learn next semester that your functions are going to, for the quadratic, it will always be x minus a number. And that number, when I read this, look, x minus a positive 2, right? And so positive 2, you go 2 to the right. Now this was x, we're going to do an x plus 2. So I want you to think about this. If this is g of x, h of x equal x plus 2 squared. This time it's plus 2, x plus 2. Students get confused with the horizontal. They see that plus 2 and they think, well, I'm going to go 2 units to the right because it's plus 2. It's not,
Those 2 units to the left.
because the function needs to look like x minus. X minus. So do y'all agree that this right here is x minus a negative 2 squared? Do y'all agree that this same thing as this?
Yeah.
And so now it's a negative 2. You see that? And so negative 2 would imply that I go 2 units which way? To the left. So when you're dealing with horizontal shifts, think the opposite of what you would normally want to do. All right, so next semester there's something called Vertex Form for this. And Vertex Form has the form x minus h. It's x minus, not x plus, x minus. And so that's where all this will come in. So you know what a vertical shift looks like. The number's on the outside. A horizontal shift, the number's located where?
Inside.
Inside. Okay, so let's go to the back page and let's do this one. So I want you to graph h of x equal x plus 2 squared. F(h) of x equal x plus 2 squared. Recognize, is this a horizontal or vertical shift?
Well, actually, I already did that on the front page.
Horizontal.
It's horizontal. Okay, so what do you think you may want to graph first?
You're
The f of x.
The parent function, x squared.
right.
All right, so you know the points. The points are 0, 0, 1, 1, right?
So you always want to graph the parent function.
Yes,
first.
because you want to use that to do the shifts.
Okay.
2, 4, right? And 3, 9. And then you do negative 1, 1, negative 2, 4, negative 3, 9. And then you connect them, so there's your parent function. Do the best you can, make it look,
Decent.
yes, not bad. Now from there, I know it's a horizontal shift. So g of x is x squared shifted, let me put g of x is x squared shifted horizontally to the, which side? To the left. How many units?
2.
2 units. And all you do is take those 5 points, or in this case 6 points, and you move them to the left. 2 units. Once you recognize that, that's easy. But you have to recognize it's a horizontal shift first, and you have to recognize which way and how many units. So it's a horizontal shift to the left, 2 units. So here's what you do. Do the vertex first. Go to the left 2. So there's my new vertex. Here's this point right here. You see it?
It's going to fall on the other dot.
Yep, right here. Now let's take this one, go 2 to the left, you get this one. Y'all see this? So you see I took care of those first 3, right? Move this to the left 2 units, move this to the left 2 units, move this to the left 2 units. Okay? Let's go to the next one. Move this to the left 2 units, 1, 2. Move this to the left 2 units, 1, 2. Now let's do this one. Move this to the left 2 units, 1, 2. To left 2 units, 1, 2, and then do what? Graph. Do the best you can. And you can actually see from there that that's shifting. You can see the horizontal shifting. Okay? Now, if you add transparency, you can actually see it better just because you can move it. You can move that transparency and see where it's supposed to be. Any question on horizontal, vertical? Huh?
It's actually kind of pretty.
What was that?
It's actually kind of pretty.
It's pretty.
Yeah, it is.
I don't find math beautiful. I find math beautiful.
Well,
She likes
it's a shape.
symmetry.
I like
Yeah.
it. I like
She likes
it.
the idea of
My niece-
symmetry.
my niece is a math professor. She loves it.
All right. Now, any questions on that? Okay. All right, let's look at this. Let's graph g of x equal negative x squared. Negative
Can we flip
x
flop?
squared.
It's gonna be-
So let's first of all graph x squared. So what are my points for x squared? What are your points? 0, 0, 1, 1, 2, 4, 3, 9, right? Negative 1, 1, negative 2, 4, negative 3, 9. And then you graph them. Do the best you can. Get this.
Missed your dot.
Yeah. Okay. Do the best you can with this. All right, let's see what happens when I graph g of x. So g of x, I'm going to go ahead and put the points here. If x is 0, if x is 0, I get negative. And remember, the only thing being squared is x, not negative x, just x. So when I do this, I'm going to say negative in parentheses 0 squared, like this. Now, what's 0 squared?
0.
And what's the opposite of 0? Same thing as what?
It's gonna be 0.
0. If x is 1, I get negative in parentheses 1 squared. What do you think that's equal?
Number 1 is 1. It's gonna be a
So 1 squared is 1, but this says it's going to be a what?
negative 1.
Negative 1. So far I want you to notice what's happening. So I get 0, 0, right?
Mhm.
But instead of getting 1, 1, I get what?
1 negative 1.
1 negative 1. So notice this x squared, the graph's going up. What do you think's going to happen here?
It's a mirror image of
The graph's gonna go
of the parent.
Down. So there's going to be a reflection about the x-axis. You reflect about the x-axis. So if you had a transparency, you can actually see it reflect about the x-axis. So the negative out here reflects it about the x-axis.
So then we could just go start filling them in.
Yeah, so what
Negative
he's saying is this: if you notice now that the points are reflected about the x-axis, can you just now go to those points you already know and reflect them, yes. So for example, now be careful. You see this right here where this was 2, 4, right? My new point is going to be 2 what?
-4.
-4. 2, -4.
And a -3 and -9.
Yeah, and then
9.
3, -9. And then this point here that was -1, 1. It becomes -1 what?
-1.
-1. This
-4.
this point here is -2. 4 becomes -2,
-4.
-4. And if you don't recognize it right away, hopefully you will at some point because you need to. But if you don't recognize it right away, put -2 in. See what happens. If x is -2, I get this. -2 is being squared. What's -2 squared?
4.
And so it becomes negative what?
-4.
-4, and that's what we said.
So
Okay.
-3, -9.
Yeah. And so you get this.
You're done.
All right, do the best you can with drawing this. Okay? And there's your graph. So the negative out there is a reflection about the x-axis. So you just take your graph and reflect it about the x-axis.
Okay, so as long as we remember, if we see that negative like that, it'll be a reflection or a mirror image per se.
Yes, about the x-axis.
Cool.
Yes. Okay, so any questions on those? All right, so for x squared, you know what the parent function for x squared looks like, right?
Mm-hmm.
You know what a vertical shift looks like for x squared and a horizontal shift, correct?
Mm-hmm.
All right. Now let's look at this. Okay, let's graph f of x equal absolute value of x. Absolute value of x. I think I ran out of graph paper. But absolute value of x.
Yeah, well, as in for you.
I'm good.
I mean, I'm not gonna use it. You need it, you need it.
Give it to me. Thank you. All right, absolute value of x. So we know what x squared looks like. X squared is that parabola shape, right? So let's think about what the absolute value of x looks like. We're going to use the same points we used for x squared. 0, 1, -1. And when I say the same points, I mean the same x values, because the y value is going to be different for most of it. So you're going to do a t-table. We're going to do the same x values. Okay, just like this. And so if x is 0, I get the absolute value of 0, which is what?
0.
0. If x is 1, I get the absolute value of 1, which is what?
1.
1. If x is -1, I get the absolute value of -1, which is 1. If x is 2, I get the absolute value of 2, which is 2. If x is -2, I get the absolute value of -2, which is 2. And so when I graph this parent function, so the parent function, and this is called the absolute value. So the absolute value,
Absolute value?
absolute.
Absolute.
Like the,
Oh, okay.
like the vodka.
I thought that was a new,
Absolutely.
No, absolute value.
okay, yeah.
So the absolute value, so the parent function looks like that. It's just absolute value of x. For the quadratic, it's just x squared. That's the parent function. So if I graph this parent function and plot those points, I get 0, 0, 1, 1, 2, 2, -1, 1, -2, 2.
Oh, that's those ones that you had to look like a V.
It's a V. So these are rays. Those are not curves. All these points lie in the same ray. So you get this V. So the absolute value of x is a V shape. It will either go up or it will do what? Go down. You know now how it's going to go down. It goes down if there's what in front of that absolute value x?
A negative sign.
A negative. Okay? That's your parent function. So you know which point you're going to use for the parent function. 0, 0. You can actually think about it in your mind. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on.
So with these, we could use a ruler or a straight edge and it'd be.
Yeah,
Yeah,
yeah, for that you could. For the curves, you really can't.
Put the little ends on.
All right. Now, I'm going to ask you this. Look at this h of x. Now listen carefully to the question. Is this a horizontal or a vertical shift?
That'd be a horizontal.
No, vertical shift.
If it's on the outside, it's a
Outside
vertical shift.
parentheses.
Okay.
It's a vertical shift on the outside, right?
Yeah.
So you have your parent function, absolute value of x, but the -3 is on, the subtract 3 is on the outside of it.
Yeah,
So if it's on the outside, just like with what we did with x squared,
everything drops 3 spots.
see x squared minus 3? If it's on the outside, it's a what? A vertical shift. Okay? So it's a vertical shift. You're shifting, so this basically you're gonna take the absolute value of x and shift it down 3 units. That's what you're doing.
Off at -3.
So do you need a t-table? No.
No.
Don't use a t-table. Just know about shifting because you're going to be needing that anyway next semester. The idea of shifting. So all these points, see those 5 points, we're going to do what with them?
Shift it down.
Shift it down 3. So this vertex becomes down 3,
-3,
that vertex.
and then everything else you do.
Yeah. So that go down 3, 1, 2, 3. 1, 2, 3. Then you get this. 1, 2, 3. 1, 2, 3. And you're done. That's the graph. So this right here is h of x. Okay? That's what it looks like. All right? That's a vertical shift. Don't get caught up in trying to figure out that t-table. I need for you to understand the shifts. The shifts are important.
Okay. So
That's what you'll be using next semester, those shifts.
You gotta take the train wheels off, huh?
Yeah. Pretty
Okay, so
much.
you said if it was outside the parentheses.
Outside the parent function, because those are not parentheses.
Yeah, outside the parent function.
Then it's going to be a vertical.
It's a vertical shift. The inside,
Just like that.
see, that's where the 5 is located where? Inside the absolute value functions. That's a horizontal shift.
And that's going to
That would be a
shift-
horizontal shift. Now, horizontal, remember,
gonna shift
you gotta
side to
think
left.
opposite of what you would think. So you would see that x plus 5 and say, oh, okay, that's 5 to the right.
No.
It's actually 5 to the what?
Left.
To the left. So with the horizontal shifts, it's the opposite of what you would think. Do the opposite of what you would think. So this would be a horizontal shift.
5 to the left.
So basically, you're going to take the absolute value of x and shift it 5 units which way?
To the left.
Okay? And so that's what we do. All right, so we're going to finish this one next class period. And do this next class period. We're going to finish this. Some of you may want to do it before next class period. But if you understand before you go, the idea of the vertical shifts and horizontal. Vertical, the number's on the outside of the parent function. So here's my parent function. Where's my number? On the outside. That's a vertical shift. The parent function, absolute value of x, the number's inside of it. That's a horizontal.
See, it looked really complicated, but it's really not bad at all. It's
Oh,
a
I'm
lot easier than I
I'm sure it
really
will be
expected.
complicated though.
I'm sure it will, but as for right now, it's really not as bad as I thought when you showed
It
it to
looked
me.
extremely intimidating.
Yeah, I
Yeah.
was just like, no. I don't
When you
have
started
time.
talking about function of x and function of this, that, and that, it was like,
I could, I need to take the defibrillator out.
Yeah.
Something.
All right, so
Call the roll.
You in a hurry?